Hello friends, welcome to my channel 5-minute class. In this video, we are going to see the second example for finding the time complexity and the space complexity with the help of the frequency count method. So in this example, we are taking the algorithm sum of the two matrices, and here we are considering the matrix as the square matrices. So algorithm is here. Here the two matrices A and B are the square matrix of order n by n. So this n is the order of the matrix. So if n equals to 3, that means both the matrix of order 3 by 3 be something like that. Okay, so here the matrices A and B are basically the two-dimensional array, right? So let us see how the time complexity of this algorithm will be computed. So the first statement, that is this for loop, how much time it will take? N plus 1. It is just taken from the previous video. We have already discussed how this n plus 1 is calculated. So in this video we are just considering that this will take n plus 1 time. So whatever inside this first loop, that will be executed for n times. So it will be executed for n times. This would also be executed for n times. Now the second loop, this loop would also take n plus 1 time, and whatever inside it, that will be executed for n times. Okay, so the time function f of n can be the sum of all of these times, that is sum of this and this one. So it is n plus 1 plus n square plus n plus n square. So it is 2n square plus 2n plus 1. So we can write it as order of n square. Okay, so when we represent the complexity as order of, we write the degree of the polynomial. So the degree of this polynomial is the n square. Okay, degree is actually 2, but we write the term having the degree, that is n square. Now space complexity. So what are the different variables we are using? We just list out. Here we are having our 2D array A, B, C, and variable I, J, and N. I, J, and N. A will take, since A, B, C are the square matrices, so it will take n square unit of memory. B would also take n square, C will also take n square, and I is a scalar value, so it will take 1, it is also 1, and it is also 1. So the space complexity or space function can be written as the sum of all of these memory units. So it is 3n square plus 3. So we can write the space function in terms of order of as order of n square. Okay, so the time complexity as well as the space complexity of this algorithm is order of n square. Okay, so this method can be used for finding the complexity of any algorithm. Thank you.